This meeting is being recorded.
Okay. I'm not sure it's recording too, but it's being recorded. Yeah, maybe just for the recording, we have been going through the outstanding questions for EOF 1, and we are discussing the validation. So I guess we actually decided for this now, right? Daniel, Charles,
Yeah, my concern about the deep validation, I think, is not a concern because we validate. This is for the sake of the recording. We basically validate each byte, whether it's a header byte or a code validation byte or a data byte. And when you recurse in the subcontainers, you skip over the whole bit of it, and then you revalidate the interior, which again falls in the category of evaluate it once for header byte, data byte, or code validation. So we're not really evaluating bytes more than once. So in any nesting dolls you get with the deploying factories, are costed for each expansion, charged for each expansion. So the computational cost matches the expected charge cost. So there's no mismatch between the gas charge and the effort expended. So I'm not concerned anymore, and I'm okay with subcontainer validation.
Awesome. Yeah, I think that the important piece is that we have to write down any concerns we may have into the security considerations, just to aid the review for others. Because otherwise, if they're gonna have like the same concerns, it's gonna take longer to get onto the same page. All right, shall we move to the next outstanding question? Which I think is create 4.
Right, so this is my proposed change. Right now, the create 4 spec is written that it takes a stack argument that references an index in a transaction. My concern is stuff like 4337, where you're taking what might be user operations that might contain these or might not, or future transaction formats, where they might be bundled together, and you might lose your index location within your transaction. Especially for taking user operation and bundling them into a type 2 transaction would have that extra field. My proposal is instead of indexes, we use hashes, and we refer to the contracts by their hash. So there's a bit of a cost overhead when you bring in the transaction. You're going to have to hash it, but if it's SSZ encoded, it's probably going to be hashed anyway. And you refer to it by hash. Now, one concern is this might be more larger code. There might be a push 32 before the create 4, but if you're embedding the hash of a contract, and you're doing it for size, then you should be using create 3 and embedding it in the EOF container. There might be some strange situations where you're needing to do diamond pattern and all that, and you want to lock in the version. But I think the more typical case is you're going to be passing in your contract hash via call data, and it's not going to be in the code. It's going to come exterior from the code. So what you get on the stack is going to get call data, or it's going to come from maybe long-term memory, and that's where you're going to get the contract to deploy. So the size growth isn't going to be too much larger. And looking beyond the current situation of the EVM on layer 1s, I think this opens up more design space for layer 2 EVMs, where they might have, especially ZK EVMs, where they might have a small list of contracts they want to deploy. And it's provided by the layer 2 outside of the transactions, and say, well, you can do Uniswaps and you can do pools and you can do Minecraft things, and that's it. And so you can refer to those contracts by hashes when you deploy those there. So you could refer to stuff outside of it. So I view create 3 as you're deploying it from within the container, and create 4 is you're deploying from outside the EVM and using a hash to reference it, where our first proposed implementation is that the hash comes from a transaction containing the data. So that's my high level pitch for why create for should shift to hashes. And we could accommodate hashes and indexes by putting in rules like if there's 31 0 bytes, then treat it as an index. We could accommodate both in this as well if we need to.
Yeah, I would be against having clever rules. I would either just go for a hash or an index. And initially, I think I mean I was leaning towards a hash, but initially only because that allows for like block level deduplication. But as you mentioned, I completely forgot about the user space account abstraction. And I think that's the main reason why I would be for the hashes, because that simplifies the relayers and any kind of building on that level. I guess the question is, anyone strongly in favor of having indexes? Anyone somewhat in favor of having clever options of indexes and hashes? And I guess we're gonna go with hashes for now and see if anybody from all codefs comes up with some arguments against.
So the implication for the tooling would be that the creation transactions would have to include hash, right, in the call data.
Yeah.
Or it would be a push 32. I guess there are some contracts where you just do index 1 and always deploy index 1. So that is the downside. You'd have to pull it out of call data and put it on the stack instead of just pushing 1. So like the creator contract, exactly.
Yeah, I mean we could have, yeah. I would try to avoid having any kind of clever rules like empty hash having some specific behavior or anything like that.
So we would just change the input from index. If we go back to that, index would just become hash salt, aux data up at the top comment line. So we would just change the ABI of the contract. I mean, it's already set up at 32 byte intervals, so it's not too much of a change. In fact, it's probably, you just change the text of initcode index to initcode hash and we're done. There's no actual structural changes to this.
Yeah, the contract will stay the same, I guess.
Right, yeah, I would suggest we go with the hash for now, just so that we actually try it out, because I guess nobody properly implemented it and tried it in different contexts. So yeah, I would try it out with the hashes and come back if we find any issues with that. Right, nobody against this proposal, then I suggest we go to the next point. Forbidding unreachable sections. Andre, do you want to explain that?
Yeah, this is just seems logical since we disallow unreachable code, then sections that don't have any call F or jump F into them should be forbidden. And I guess it was like an oversight from our side originally, and we never got this into the spec, so seems to be a good idea to me. The only downside is like some testing might be more complicated because you can't just create like, I don't know, 256 sections like to test the limits. Each one of them should be reachable and things like that. Yeah.
I think it's fine because I think creating a test case to do max sections won't be too hard. Every section just becomes jump F next section number, and then the last section becomes stop. So I think it's a minor, and I think it goes along with the theme of no dead code, and I think that's an important thing to get.
Yeah, I don't think this is controversial. It just falls under no dead code. It's just a section which is not reachable instead of a basic block, right?
All right, I mean, let's do it unless we find some issues along the way. And then we have this section for changes which can be rolled out in a different stage. There's just one feedback, at least from within the Epsilon team, I think where we have been mostly leaning towards is it would be nice to spec these out, but probably we wouldn't push very hard to have optional opcodes, just for the reason of having too big of a scope. But specking out jump FI and maybe the create with external address could be useful for the point of realizing if there's any shortcoming or any issue elsewhere in the design. But I wouldn't push hard to actually have them in like the first stage or first rollout, because the scope is already like quite significant.
By the way, I don't know if I should have mentioned at the beginning of the call, but I submitted pull requests, one for return data load and one for this exchange opcode. So return data load is already spec'd out if you want to accept.
So exchange is the swap MN, right?
Yes, and something interesting that Dano and me figured out is that the addressable range is actually larger by a factor of 2. So like with 1 byte, you can actually address 32 stack items instead of just 16.
Yeah, if you assume you're never swapping 1, because you use the existing swap set. So it's 1 plus for the first, and then you order them first and second, then you encode the second one as a delta from the first, again, offset by 1. You can get up to 32 for your maximum swap. The downside is you can move at a maximum of 16 spaces on the stack, but sometimes that's what you would need. So I think that also makes sure that there's no duplicate swap instructions, like swap 7.6 isn't the same as swap 6.7. So
yeah, basically there's a bunch of duplicate swap instructions. Swap 1.2 is the same as swap 2.1, and also swap 1.1 is a no-op. So you can basically Dano's encoding is better because it doesn't waste space.
And what's the number for exchange?
I just made a pull request against the 663 IP. They're all in the Discord chat. But I can.
Oh yeah,
link-
663.
All right.
It makes sense to just put it in there since that's the successor to swap N that's more functional. And dupe N would remain.
Posted the pull request in the chat.
Let me link this into the discussion actually.
Would it help for me to submit a pull request for Jump FI?
Yes, I would say so.
I'll try to do that today then.
Yeah, I think that one we could actually try to get into the existing EIP, right?
Yeah,
Should
I
we
think
create
that can be part of Jump F.
separate one?
Because Jump F, I mean, I was thinking about it. Excuse me. And usually instruction sets don't have this conditional call instruction, but instruction sets also don't usually have Jump F, which is like a tail recursive call instruction. So I think under the logic that these are specialized call off instructions, it makes sense.
Yeah, JumpF is 6206. Yeah, at some point we actually wanted to merge that back into the function CIP, but now it covers the non-returning aspect. So yeah, maybe it's better to have it separate. So like JumpFI could go into 6206. Yeah, I think we're on the same page that speccing out cannot hurt, because speccing out would tell us if there's any other issue or shortcoming elsewhere. But at the end of the day, I probably would be willing to drop JumpFI if that's needed to get the rest of the features in, and probably the same. Yeah, I don't have like a strong opinion which swap or exchange version should we have, as long as we have at least one. Okay, do we actually have anything to discuss with these? I linked the IPs. Yeah, Charles, is there any like, do you want to give like a short overview of return data load?
Sure. I mean, it's basically exactly what you expect. It's 3 gas. Yeah, if you pull up the pull request. I added a little bit of motivation for it, and it's, yeah, there's the spec of it. It's 3 gas. It takes the offset from the stack. Exceptional failure if there's an out of bounds, and otherwise it just puts the word that it reads back onto the stack.
And the main reason for this, because you do utilize in Viper the fact that calls can write some of the return data, right? And you write like, I don't know, the first. I mean, how much do you write?
Sorry.
So I guess this return data load is for the fact that the old calls would
Yeah.
write the return data as well, right?
Yeah, use the output buffer and then decode from the output buffer. And then to restore that functionality, we need to be able to treat return data kind of similarly to how we treat memory as a buffer. And so return data load kind of replaces the usage of mload here. And otherwise, there's something a little bit weird when you need to. So normally you just, let's see, how do you put this? So normally when you use a call, you specify the output buffer, which is like offset in length. And then the EVM implementation will just truncate the return data if the callee returns more than what's, more than the buffer size that's given. But without that, you have to do it in the EVM. So in order to copy return data into the output buffer, you need some sequence of instructions to like calculate the minimum of the return data size and the allocated buffer size. And I don't know.
Wouldn't actually.
But Viper
Wouldn't actually
allocates statically, so you can't like really. You have to bound it statically instead of at runtime, or you want to bound it statically.
Yeah. So I think I have two different comments. I think from Solidity's perspective, if I remember correctly, Daniel said he would be super happy with return data load, just generally, because it's nicer and a counterpart to call data load. But for your specific situation, and also Solidity has been complaining about it, but I kind of wonder if, and probably we discussed this on the last call as well, but kind of wonder that the underlying problem is not the lack of return data load, but rather that return data copy is not zero padding. Because if it would, then you could just keep calling it without taking care of the return data size, right?
No, that's not really the issue.
So what is the main issue then?
The issue is like what happens when you go to ABI decode the return data. So let's take a very simple case where like the contract returns a uint 256. So right now what you would do is you just call and then you provide an output buffer, which is like 32 bytes. And then, excuse me, the return value is just what you get when you mload from that buffer. And then in the new thing, you need to call return data copy and then mload return data copy into some buffer and then mload from there. And when you go to return data copy into that buffer, you need to make sure at EVM time that the return data size fits into the buffer. Basically what happens is that in order to ABI decode things, you basically need a buffer. So the first thing you go to do after calling some contract is copy stuff from return data into a memory buffer. And if you have return data load, then you don't need to do that copy.
Yeah. Although this last argument, I mean, right now you do designate some memory area, right? Because you use the output buffer option of the calls.
Yes.
So I think that part may not be like the strong part of the argument. But I do have one question. What happens when you try to return data load out of bounds. Is it
Yeah.
returning 0?
No, it does the same thing as it's consistent with return data copy. So that's step 3 here.
Yeah, this part I would definitely discuss with Solidity.
Yeah, and this is kind of a weird thing, and we discussed this for a little while in the last call. But for now, at least, it helps ABI decoding because another thing you need to do when you ABI decode is like validate. You need to do certain offset validations, and this kind of gives it to you for free. The out of bounds return data behavior. So it basically allows you to not do return data. It allows you to skip return data size checks, actually, which I don't know if that's considered a trick or not. But and then it's also
Do you actually?
Sorry.
Sorry, say it again.
Of course, it's also consistent with return data copy, which is maybe the most important thing.
Yeah, but also return data copy is the one tiny piece inconsistent with the rest of the EVM, right?
And we discussed that at length in the last call.
But do you have some actual numbers in what kind of regressions you get without this?
I posted the EVM snippet that's required. It's like a 10-byte piece of code or something for every call.
Yeah, I mean, I personally don't have strong arguments against having return data load, but I do have concerns regarding the semantics. That it's really hard to actually find a good option because I mean, there are just so many different sides to it. But
I mean,
what is the opcode count at this point?
do you mean the exceptional failure semantics?
Yeah.
I think that it's actually best and most forward compatible, future proof, to make return data load and return data copy 0 pad, which is maybe unintuitive and not the most popular opinion, but it makes it easier to pack return data. But let me think about this because call data and return data are priced very differently. So maybe you want to do something like call data is packed, so it makes sense to 0 pad it, but return data is never packed or something like this. So maybe it makes sense for return data to not be packed, and so we do charge the out of bounds thing. But I mean, that's a really weird thing that just comes from how call data and return data are priced differently to fill.
All right, just trying to fit in the entire conversation in 60 minutes. So, so we discussed, I think, return data load to some extent, the exchange to some extent, and there are 2 more points here regarding jump FI, and I think what we discussed there, just to recap, is that we are going to at least spec it out and see if we run into any issues.
By the way, I think Andre's
guess-
less restricted stack validation might work too. Andre, it's you have strict stack validation on backwards jumps, but not strict validation on forward jumps, right?
Yes, something like that.
Yeah, I think that's actually fine because it prevents this unbounded thing happening when you have loops. But it does kind of what you want on forward jumps.
Yeah, exactly. It kind of still disallows unbounded loops, but allows jumping into one forward location from different stack heights.
Yeah, I think it's a really good compromise actually because it's easy to reason about from an implementer's perspective. I think I had a proposal before which removed the stack validation entirely, which is like produces some hard to reason about cases. But it also removes the relevant restrictions that as a compiler writer I'm concerned with. So from the point of view of the compiler, it produces the desired effect, and then from the point of view of the implementation, it's not too complicated either. So what's
Yeah,
the
I'm
best
actually
way to
not
move
familiar.
forward on that? Sorry?
Yeah, I'm not familiar with the stack validation changes here.
Yeah. The reason JumpFI was proposed is because the stack validation rules are in some sense too strict. So they require you to add all these branches in code that just used JumpI before. So there were two proposals, right? One is JumpFI, which rolls RJumpI and JumpF into one instruction, and then the other idea is to loosen the stack validation rules, and that's one of that approach is there's one approach which Andre implemented. And I think it's actually what WASM does, which I remember reading somewhere, but I couldn't find it. Which is they have strict validation on backwards jumps to prevent unbounded loop things, but less strict validation on forward jumps.
Yeah, can one of you maybe explain the difference? Because it's only just, less strict, what has been said so far. What is the restriction? Exactly what has been lifted?
Restriction is the requirement to all jump just to have this equal stack height for every path that goes through this location. So this is Viper's concern, and I think Solidity had similar, is that they want to jump into some helpers from different stack heights, not from constant stack height. And this is not allowed in current stack validation. You have to balance stack before jumping somehow.
Yeah, I mean, that was also one of the reasons non-returning functions were kind of introduced. Would this loosening allow us to remove the non-returning functions?
Maybe.
And I guess this particular question maybe needs a bit more focused effort. Probably it's not like
Sorry, what
it's
was
not
the
like a
question?
blocker for tomorrow. That the less strict validation would that also allow us to remove the non-returning function special case, because those were also introduced because of stack balancing reasons. But in terms of tomorrow, I would probably argue that this one particular question is something we can let slip. I don't think this is going to be like a blocker for tomorrow. And specifying jump FI, I mean, Charles, do you think you're going to get it done by tomorrow? Yeah, I don't think
Yeah, I
we,
can send over a draft, and then it would be helpful if people look over it.
yeah, I mean, let's maybe try to see the implications, but I don't think we're going to make a decision on this today. And I don't think it blocks the presentation of tomorrow.
Right. It seems like a bit of a detail. But I think in terms of choosing which direction to go, I think it's kind of important.
Yeah, I don't think we're in the position on this call to make the decision. I don't think we have, at least I don't really have good enough context. Yeah, at the minimum we should, yeah, this is also something we probably really want to get feedback from Solidity. So probably the best course of action is describing this problem in detail, and then the two different options we have in detail. Yeah, I would suggest that we try to craft the one pager explaining this, the problem and the two options, and then get feedback from at least Solidity. And potentially, I don't know, Pavel has been like super involved with the stack validation, but I'm not sure when he's going to be available. But at least Solidity should get feedback. Is anyone volunteering to write it up?
I can try to write it up, yes.
Awesome. Yeah, maybe we can come back to it also on the next call just to finalize that. Okay, should we briefly discuss this last point? Create tree with additional address.
No, I don't think that's important. If we need to choose one thing to talk about, can we talk about exchange for a little bit?
Yeah, I do want to set aside at least 5 minutes, which would be the last 5 minutes. I'm not sure if people have a bit more time, but to discuss like tomorrow's presentation. I'm not sure, Dano, do you, Dano, Charles, do you have 10 more minutes?
I've got a lot of time.
Yeah, sometime.
Right. Yeah, let's discuss exchange then.
So originally I actually drafted two, the pull request with two different exchange opcodes. But then Dano and me realized that this single exchange opcode gives access to 32 slots, and so I just dropped the second exchange, but you can add it if we want access to 512 slots.
How do you get 512 slots? 256, I thought's all we get with one immediate arc.
2 immediates, two bytes of immediates.
Oh yeah. You're right. Okay. If we use the exchange with the 2-byte immediate, got it.
Yeah, exactly.
Yeah, so this exchange is n plus m. And the arguments are unsigned, right?
Right. Because if you're ordering any 2 items on the stack, you can strictly order it. One comes first, one comes second. And the first one has to be within the first 16 bytes. So you have 0 mapped to 1, since we have swap 1n already set up. So you would add 1 to the first value. And then you would have the 0 index. You would add 1 because it's at least the one after, and then add to the remainder. So I think we actually get 34 bytes maybe, or 35 bytes of depth, but it's 32 is the easier one to sell logically. And we could be precise later. But the point is, with the nibble approach, there's no wasted swaps. So if you swap 6-7 or 7-6, those would swap the same things. So we do the encoding so it, is first one and then delta for second one. So we get more distance out of those duplicate combinations per se.
Yeah. So my original thing, which was swap NM, actually more than half of the instructions are duplicates. So like swap 1-2 and swap 2-1 are the same, and then swap 1-1 is also a no-op, and swap 2-2 is a no-op, and so on. So it's like half plus there's like some kind of matrix, right? Anyway, a lot of them are duplicates, so you can get a better
So
idea.
why don't you offset by 16? So n starts at 16.
I think n could start at 2.
I think we want to start at 2 instead of 16, because that gives us space if we need to get rid of the dupe n 1 through 16 to use for other things with a minimum of disruption.
Yeah, and if we're gonna do that, then we should also make dupe n start with from 17 or whatever it is.
Well,
Yeah, but what I don't get, and I haven't tried it fully, how do you, I mean, this currently can only go to like 32 items. How does it goes like deeper?
swap.
33. Yeah, I think that's a good thing.
Sorry, I didn't get that.
I think it's 33 if we start from 2.
Yeah.
Yeah, I mean, I started out by saying that, with the 1 byte immediate, then we can address 33 items, or 32 or 33 items, and then with 2 bytes we can address 512 items. But yeah, so I originally drafted it with exchange and exchange 2, but then 33 items felt like kind of enough, so I dropped exchange 2.
Yeah, I think Solidity had like different problems. They wanted the depth as opposed to swapping any 2 items. And for that, I mean, this won't be as useful, right? Because the swap n can go to 155.
I mean, yeah, I mean, you can ask them.
Yeah, I think it's the same as with jump fi. This really has to be discussed with them as well. So maybe for the next call we can actually properly a range to make sure that somebody from Solidity comes on. But I think we should do this async. Yeah, in fact, I'm gonna send it to Daniel to see if he can review this PR. Yeah, because it's very different problems it's trying to solve, right? And it has different trade-offs.
Yeah, I mean, there's kind of similar and related problems, but it is a trade-off, especially with respect to like code size versus number of opcode slots. Like if opcode slots weren't an issue, then we would just add exchange 2.
All right, yeah, I'm not sure we can make any more progress on this on exchange. I'm not sure, Andre, do you have any opinion?
Not really. Yeah, we should ask Solidity.
All right, should we discuss these last nice to haves on the bottom?
I like data section optional. The question is, if it's 0, do we require its absence, or do we allow it to be set to 0? And I mean, in the issue with fiddly little rules, we could say that, well, I mean, the data section has to be, when you're using a subcontainer, if the rule is that your data section needs to be the actual size of the final contract, not what's in the subcontainer, then it doesn't matter. Then we're not going to rewrite the data. We're expecting a fixed data size. We're not going to rewrite it. So that might get rid of the whole rewriting issue. So if there's 0 data, then I think if we're not going to change the data section size, I think we not only make it optional, but we prohibit data size 0 in the header. This all, of course, hinges on whether or not we rewrite the data section size.
But I think this downside listed here, pending data section, maybe more than just appending them. I mean, that's a problem of the compiler. The compiler wouldn't, I mean, it could choose to do so, but it would likely just include an empty or short data section if it expects it to fill it up, right? So it's still a choice made by the compiler.
Right. So go ahead.
No, what I meant here is we are, so with this spec where, like the previous spec where data section declared in the header is equals to its size, and then we append and update the size value in the header. In case it was empty and then it becomes non-empty at return contract point, then it will be not just appending data section, but also inserting this header in the subcontainer header, inserting data section header. But this is not a problem if we go with allowing truncated data sections, then it's not a problem actually. So it gets simpler. Then appending is really just appending the data section.
Yeah, exactly. But what I meant is the problem of the compiler is that the compiler would know that it will want to append data, so then it would prepare the deployment code to have the header. This only really comes up as a problem if you do have a create tree with external address for the init code. Then you may need to extend the headers, right? But that's like another problem generally when you take unknown init code that you need to check whether it satisfies what you expected. I mean, yeah, of course, the compiler can shoot itself in the foot with more optionality, but I don't think it's a downside. It's really up to the compiler.
I'm not sure I understand, because like this, what I meant is complexity of the implementation of appending of the data section at the return contract point.
Oh, you mean in the client?
Yeah.
Right. I mean, yeah, I guess the one option is that if you're pending and there's no data section, then that's a failure, right? And then there's no complexity.
I mean, now we decided anyway to allow truncated data sections, and then if you intend to append later, you will declare its size already, and it will not be empty. It will not be an empty header.
Maybe this is a stupid question, but are data only contracts allowed in EOF? So no code sections?
No, not all.
But you could trivialize it, just have one code section that's just a stop byte, which would have the effect of, or have the invalid instruction, so you can't call it the explicit invalid or the revert. So you could get around it with minimum of header impact. I know that's something that like the STOR2 people are going to want, which is they either want ext data copy or they want a way to get at it. So they intend to put some data in these contracts like inscriptions.
I'm just wondering if some of the same considerations apply here.
What if they're putting what if they're putting links in that are longer than what's in the section? Like that might be it. Or variable. That is the downside, but I would expect they would deploy their data contracts via top level transaction, to be honest.
Actually, what is the motivation for making it optional? It's just to save
Reduce the
bytes.
header size for contracts that don't use it.
Yeah, it was made mandatory just for the ease of parsing at some point of last year, but then we added container sections, which are optional. And now we have data section mandatory, but container sections optional, and it's kind of inconsistent. And the argument for simplicity of parsing doesn't stand anymore, kind of.
Yeah, I guess the init container stuff is a good point. But based on that logic, if we want to support data contracts first class, then we also want to make code sections optional, right?
That's the definition of data contracts, non-code section, so it must be optional.
Yeah, I guess what I mean is you could argue for either of these options really. Because you could say that the init, the subcontainers case is the special case of creation, and the others are regular contracts. But yeah, I don't have a strong opinion. Yeah, as I said, you could argue for any of these in various different ways.
Okay, I would opt for no change then, like, leave it like now, or so make it mandatory.
With the create hash though, you could still put in a stub that's the same and then have a variable amount of data that comes after it. My expectation is that's how the STOR2 people would want to do it. So they'd have like a stub that has their interface to read the data, and then their data structure, the first byte will be how long it is and segmenting and other info. And then it's a variable length after that. So I think a fixed length contract might be of less utility for them because create for still has an auxiliary data option to put in it too.
By the way, one issue with relying on the S-store contract to return data is that you kind of have to trust it. So it opens up things like reentrancy or the data contract not doing what you expect it to. And this is actually some kind of issue with that I was trying to solve with the create 3 variant, which is like, yes, you can call this dedicated factory contract, which is supposed to deploy a contract for you, but you have to transfer execution context, and then it makes tracing more complicated too. So like with the S-store2 returning data contract, now every time you want to do an X data copy, you introduce kind of a trace, a call into the trace, which I don't think it's necessarily considered like a showstopper, but I think it is kind of a consideration.
Yeah, I do think ext code copy is going to be a better solution for the STOR2 community. Ext data copy. Sorry, not ext code copy. So their code might be nothing more than basically stopping payments and stopping any calls and throwing exceptions saying I'm a data contract, please try again later.
Yeah.
Or please don't try again.
That should be considered together with the create 3 variant, because they're both kind of doing the same thing, except just one is a call context and one is a create context.
Yeah.
But I mean, as a compiler writer, I have no opinion on whether the data section is optional or not. I think it's fine either way.
So when people are micro benchmarking, it would be nice, but how many tiny contracts are deployed?
It's not only tiny contracts, but if you look at, I mean, at least for Solidity, if you look at Solidity contracts, we have immutables, because that's like cheapest way to store variable data, write
right,
once.
which is why we need Aux data. But also let's
Yeah, so
consider
it
that any real contract's going to be putting in its metadata, its hash, it's the trailer CBOR stuff anyway. So not many contracts are going to have
yeah,
zero
true.
data.
I mean, that's for Solidity, but the question is then for Viper. Charles, do you think you're gonna have like a large number of contracts not having data?
I don't think that the overhead of the data section is that significant. If we're talking about code size, one thing I do think is significant is the size of the code section header, because if I recall correctly, it's like 6 bytes or something per subroutine, which is a little bit significant if you have a lot of internal methods.
But how could we encode the data so we have it for stack validation?
I mean, you can just choose a more compressed encoding for all the offsets and lengths, I think.
So let's just leave the data section required. That'll solve it. It's more effort than return to get consensus on it. So let's just keep it as is inspect.
Yeah. Yeah, it's not a
Yeah, that
significant
leaves.
overhead, but what is a significant overhead is the size of headers, actually.
Yeah,
'Cause, like,
speaking of size of headers, the last point is adding one more field. So should we maybe discuss that first? Andre, I'm not sure. Is it you who added that?
The max stack height, you mean?
Yes.
Okay.
Is that for
Yeah,
code section or for the entire contract?
this is for code section. This is a minor change in validation, and so we allow max stack height in the type section to mean not exact equal max stack height, but like upper bound. So for tests, it simplifies life because you can put there just max FFFS and then like any code is valid with that. Otherwise, like currently for testing, you have to calculate also the stack height of the code you wrote. So current validation is we do stack validation and calculate during that calculate maximum stack height and check that that calculated stack height equals the one declared in the header. And this proposed change would check that calculated stack height is less than or equal the one declared in the header.
So a lazy compiler could just say 100 and just be done with it.
Yeah, exactly. And like it's useful to have lazy compilers and testing scenarios.
Is this what I think this is what .NET does. Is that what they do in theirs? I guess my question is there precedent for this in other VMs? Because if there is, then I'm cool with it.
I don't know.
I don't actually understand what the difference is from the current behavior. Isn't max stack height just the total, the upper bound of the number of stack items in the code section?
So currently it's not an upper bound, but exact value of maximum stack height that code section may reach.
Oh,
Right. It's whether you have to bingo it or whether you just have to be less than the number when you run your calculations.
for compiler, from the perspective of the compilers, it's better to just be upper bound instead of match exactly. Because, right, like Dana said, you can just kind of be lazy.
So it affects call F in a way that this value is used at call F validation or at runtime maybe. So if you declare like max upper bound for each, then you will have a lower maximum call F stack depth.
It is a foot gun, but if we're talking about lazy compilers, they're probably not concerned about max recursion.
I don't think that recursion is the problem. I think the problem is more catching compiler bugs. Because it's a foot gun, right?
Yeah. But the space this opens, I think, is some of the stuff that we were looking for to allow variable stack heights to come into terminal operations. I think that's why we were discussing this. So like you have that one function that is, well, actually this would have been in the inputs and outputs variable. No, because that'd be inputs and outputs. Anyway, I thought you were, I thought, Charles, you were talking about times where you'd want to have everyone share a revert, and you don't want to have to care about what the stack height is when you're going to throw a revert, as long as the top 5 arguments have all the information you need. And then you would go in and you would revert it. I thought that was the value that this would add.
I don't think they're directly related. Because this is just the max stack height that happens in the called subroutine, right? It makes it like not a black box. Because you can call a subroutine and then it can blow up the stack.
Yeah.
It doesn't have to do with its inputs and outputs. And like, yeah, so I mean, like the lazy compiler approach is just make max stack height like always 1000 or like 1024 or something. Andre, can you explain how it simplifies testing again?
So just currently when you write a test and you make a container, like, well, we do it mostly by hand, you have to calculate also the code's max stack height. Because validation requires it to be equal. The declared max stack height in the header must be equal of real max stack height. And like if we, with this proposal for testing, we can be lazy and just put 1024 in each test, and then it's fine.
Right. I think for the
You mean
compiler,
255 because you only have 1 byte.
It's 2 bytes, I think. Yeah, it's 2 bytes.
I think for the compiler, it doesn't matter exactly, but the strict validation is a little safer. Because it's kind of like it's a little bit like a checksum bit, right? Like it ensures that the thing that we're declaring in the header is actually matching what we did when we analyzed the code before we outputted it.
Yeah, this might catch some bugs at compiler development time.
Yeah, exactly. I mean, yeah. So if there's like a bug in the compiler, just like the contract like just won't deploy, it'll fail validation. Yeah, and in terms of the testing, I think there's actually a way you can cheat, which is just to do the same thing, which is like you calculate the max stack height that happens in the subroutine and then paste that into the header. I don't know if that's like an acceptable thing.
Yeah, that's should work probably too. Like if we pull the stack validation algorithm into testing too. Yeah.
Yeah, I don't know how circular that makes things, right? But I don't think that is any worse than putting 1024 in every header. But what if each call frame had its own stack? Then it would be more the abstraction would be less leaky. I think the interesting thing is like inside of a subroutine, you can't access things that are outside of the call frame, right? So there's no benefit, I think, to enforcing the global stack restriction. Unless I'm misunderstanding that.
Yeah, I think we have been 90 minutes into the call, so maybe we're less fresh to think about this.
Yeah, let's transition to the ACD strategy, and we can pick this up next week.
Exactly. Yeah, maybe just a small intro. We had a discussion in Epsilon regarding this, and our view was that we just want you to present the facts and basically show where we are and what is a reasonable time frame. Because if we just go in there with uncertainty, okay, question 1, 2, 3, all of these are like still open. We're just trying to figure out. Then it suggests that this is going to take forever. So I think we have to be more confident in the presentation, and we can only be confident if you're confident internally, right? That we have like a good enough specification. Yeah, I think that's basically the short summary. I think we wanted to probably spend like 10, 15 minutes tops, get some slides on explaining the different pieces we have. Obviously, it's not I don't think we need to do like a recap, like a 50th recap of what the header format is, of course, but rather what kind of components we have in the design system, because we have so many different sets of instructions for different reasons. Yeah, I'm not sure. Any other like any reflection to what I said?
I think those are good, but I think we also probably need to start the discussion off with some of the bigger objections. One of them, we need to be clear we're not replacing legacy, that EOF is going to be parallel to legacy. And then that 90% of the code between legacy and EOF is reused between the two. So we get rid of the concern that we're bringing an entirely separate system in here and focus on that EOF is just a container format. And then I think we should pitch the benefits and that we can break things that need to be broken, unless the things we're going to break.
So I'm just
Gas
trying to keep a note.
observability. Huh?
Can you say I'm just trying to keep a note. Can you say like the first piece again?
The first piece I would
That it's-
probably about the legacy and the container.
Exactly.
So
In a single sentence.
EOF is a container format that will operate alongside legacy EVM instructions. It uses 90% of the same code to execute the evaluation. It just changes how we package the EVM instructions. So that way, I think one of the big objections is if we're going to rewrite EVM top to bottom, why don't we just bring in my favorite alternative execution framework? So we make it clear what we're really changing is the packaging format, and that it's mostly the same. It's almost entirely the same.
Except it's not, right?
Huh?
Except it's not.
Except it's not. Well,
Yeah, except
you still have message frames, you still have opcodes, you still have storage, you still have transient storage, you still have memory. The main things are all still there. So I think the next point that we would want to make explains why we even do this container format, is that we're taking the opportunity in a container format to break rules that can't be broken without a structural change. We're getting rid of code observability. We're getting rid of gas observability. We're allowing new opcodes with immediate arguments. Those, I think, are the three big things that we're getting in there. I had a list of other things we were breaking. Oh, address space expansion. Maybe put a star there that we're not committed to that. But if we're going to do it, this is where we should do it. And we can break fundamental issues in the container format that we just could not even address in the legacy format. So I think that sets the table for need. And then I think we can go into the overview of what are some of the features we're adding that this allows us to add, like code validation, containers, how we're dealing with code observability issues.
Yeah, when I said it changes everything, I think it's a good framing. But exactly like point two, I think it goes against the notion of one. It's just a container format, but we have changed everything. Yeah.
I think
But
one
it's fine to me.
I think that one objection that might come up is like, why not WASM or some other VM? Because EOF is significantly different enough from legacy EVM that people might be like, why not just use some other?
Honestly, I doubt that would come up, because WASM doesn't fixes any of the problems we have.
Gas weaving's problematic.
Observability and any of these.
Any language that doesn't have a gas construct is going to be a hard sell, because that's the halting problem solution.
Yeah, I mean, Stylus does this now, right? They have something which injects gas metering into WASM code.
Yeah, I mean, eWASM did the very same, but eWASM and Stylus and the parity version of eWASM and all of these things, they they basically bring WASM to where the EVM is and doesn't do anything more than that.
Yeah, I'm just
So any
I'm
of
just saying I
the,
think
the
that it's worth it to be prepared for that line of questioning.
yeah, I wouldn't be afraid of that, to be honest, because WASM has been like killed off like several times on all codevs. And I
mean,
think
the other
the
things we'd
answer
have
is
to-
simple. So yeah, I mean, just the answer is simple. It doesn't actually solve the main problems you're trying to solve. Which is any of like the code and gas observability, upgradability, etc. But yeah, Dano, you wanted to say something.
I was about, well, I mean, there's so many things you have to change to WASM anyway, like getting rid of floating points. You need a standardized gas weaving that's been rehashed, and there's a reason it hasn't gotten large traction because and the performance isn't that much better. I think that was one of your presentations in Osaka was to that effect that we tried to make it fast, but we couldn't without doing strange things like moving math into precompiles. So
Yeah, for the use cases we have, it doesn't bring us many benefits, but it has basically zero overlap with what we do in EOF. With the original version of EOF, the overlap would have been much bigger because that was much closer to, WASM and conceptually. But after code and gas observability changes, we are in a very different area. But yeah, Dano, I was keeping notes and you get to the overview.
yeah,
Do you have any?
I think
Do you
I think
understand?
that's the big. I think those are the big things to expand on the overview. I think this is the wrong crowd to pitch the EVM's the nexus of all smart contracts in the future, because I think, well, I mean, one thing we might want to bring up is, what if there's EOF 2 and EOF 3? The first answer is we're going to try and break enough things that we don't have to do it for 5 to 10 years, ideally never. But with the structures that we have with code validation, we can engage in transpilation. We can take, let's say, EOF 2, we need to get rid of all the dupes and swaps. It's a fairly mechanical process to take EOF code in that EOF 1 into this hypothetical EOF 2 and mechanically translate the code because of the code validation. So that's one advantage. This is probably at the end of the presentation or maybe as a backup slide in case someone asks, well, what happens with EOF 2? We could translate EOF 1 to EOF 2 as needed. In fact, I think it's possible to take all EOF 1 code, barring size and gas equivalents, and reverse compile it down to legacy code. I think everything we do here will be ugly, but it could be done. So we could still transpile it into the equivalent bases. So going forward, there would be legacy code. Maybe that would be shut down to new deployments on mainnet, and one version of EOF. And if we upgrade a version of EOF, we would have to have a way to describe how you go from EOF version 1 to 2 as part of your transition. But that's 5 to 10 years down the road if we do it. And the greater ecosystem pitch is, what if there's layer 2s that only ever use EOF? This is great for ZKs because we do things like get rid of dynamic jumps. And some of the other code validation makes it friendlier for them. We could cross compile it into WASM if we wanted to. I mean, there's nothing stopping you from cross compiling your EVM today into WASM. And I think maybe an overview of the high level features like the containers, and what each EOF what each EIP provides and how it fits in.
I think to present that, it would be helpful to have like a working compiler implementation that proves that you can take EOF and compile it to something else, either EOF 2 or WASM or whatever it is. Or
Yeah,
at least
that would make a compelling pitch, which is why I think it belongs in the backup slide. Because I don't know, I'm not aware of any transpilers that are ready for that yet.
I think as Greg Colvin has been pointing out for a long time, you can't write a compiler for current EVM, legacy EVM.
And that's, well, a constant time compiler. And that's where the code validation and stack validation comes in, and the dynamic jumps. It's easier to write compiler bombs for dynamic jumps. The big thing is you could have the stack value for the jump come from call data, and could have it go into big old nest of arbitrary jump tests. So the amount of compiler contortions you have to do to that quickly escapes linear time. So I think that's where Greg's main complaint is. And that's really fixed by code validation and static jumps. Which I think is what his 615 was trying to address.
Yeah. I mean, even if you can write a compiler, it's like significantly harder, right? As I think anybody who's worked on the EVM kind of knows.
Right. Well, because what Greg wanted to do was to do just-in-time compilation, where everything was just-in-time compiled straight into your local opcode. But Java's known for a while that there's some compiler things. So Java's written a mixed mode where you do mixed interpreted or mixed compiled. And they go the extra mile. It's like, well, you can make some assumptions, like if you know this field never changes from 0, you could just compile it in as if it's a constant. And they do fancy things like if they detect the field changing, they'll go and validate all that code and do interpreted. I mean, this is some high level stuff that Java does, but the amount of, risk to return, I mean, they're always finding ways to break the compiler in every release of every dot release. Someone's found some silly corner case that does strange things.
Yeah, isn't the JVM stack validation spec like 160 pages or something?
Sure is. It's
So
crazy long.
A good way to frame it is like it improves maintainability of the EVM.
Yeah, that's one good way to phrase it. Yeah. I think the reason that I have to look at the spec again, why some of those sections are like 160 is they go into detail for each and every opcode. And they also need to worry about backwards compatibility clear back to Java version 1.1 or some really far out there requirement where they've changed the class file formats and they define the equality between each of the different formats. So that's why I think the strategy of one EOF would solve that, because there'd be one transformation into it and then we just deal with one format. So, and there's proofs in their spec.
So for tomorrow, I mean, I do like your proposed structure, but on the detailed overview, I mean, the point 1 and 2 probably gonna take like 2 to 4 minutes. And that means, we have like 10, 12 minutes if we want to keep within like a 15-minute bound, which I think would be good. Otherwise, people are gonna get tired.
Right.
So 10 minutes for the overview part, which I think means that we definitely should give a clear overview of what kind of EIPs we have and what kind of problems or categories of changes each of those focus on. But obviously we cannot really dive deep into the EIPs, and that probably would be overkill anyway. People will get like extremely tired. But do you have like do you have a good idea of how should we group the features?
Let me grab here's a talk I gave at Chicago. you'll want to start looking at slide 24. I grouped them just by EIP. So I talked about static relative jumps. Then I talked about code sections. So that was 4200, 4750 code sections functions, 663 unlimited swap and dupe. We probably want to revise my slide there to consider exchange. We don't have an EIP for data operations yet. Explain how this is to deal with. And I probably explained for each of these how these address one of the required breakage things. So data operations, we would explain that we need to do this to replace all of our code introspection things. So I list, why we're banning opcodes and why this replaces those. And I think the data operations is a big one that's going to need that pitch. Slide 28 is create 3 and create 4. And then call 2, delegate call 2, how that's dealing with gas. That's 76, 70, 69, 35, 40 EOF code validation. And then there's a small list of other things. So actually, maybe I should share this. Let me isolate this. Share screen. Yeah, so as far as so start with container layout, and I just blew through this really quick. But 4200 static relative jumps. Just talked about why we need those 3 and what they do. Did deal with containers yet. Code sections and functions. Then talked about that. This is new functionality. It's not breaking things, but it helps code size and reusability. Unlimited swap and dupe, like I said, we would need to update this for exchange. I like putting this up here because it's got a low EIP number, so we can really pitch that we're dealing with long-standing problems. And the reason I would say that this couldn't be done until now is because of the immediate code. Because when I started this presentation, is to a relatively audience that was unaware of a lot of EVM. I told the story of how adding relative jumps just couldn't be done and what broke it. I think everyone on the call is probably aware of that, so we probably don't need to tell that story. But like unlimited swap and dupes, we couldn't do without more immediate arguments. And this solves a lot of long requested features. And then the data operations, again, we talk about this in context of if we're going to break things like code observability, here's what it takes to replace it and get the functionality we need. Same with create 3 and create 4. That's the other half of code observability. We need to be able to create stuff without putting the bytecode into memory. And then call 2 and delegate call 2. If we're going to break gas observability, here's what it looks like and what we would need to fix it. And call code's just a bonus. Code validation. This is mostly, I don't know if it's necessary to break. Well, we are breaking things. We're not letting just random garbage go out there. But the value that we get from this going forward is we can do more logical transitions from past versions of EOF to future versions. And then other EOF interactions, some other random things that we needed to deal with, some corner cases. And stack validation, this allows for deeper compiler black magic. And this is an AI-generated thing. I said, generate Terras of Hanoi. And computers don't get how to play Terras of Hanoi, because this is like the wrongest thing you can do in Terras of Hanoi. So I think that's a great explanation of how we can do that. And then I listed the feature bubbles, but there was one slide that I focused on compatible versus incompatible changes. So I think this is probably another point we need to make. Are we going to add features to the EOF? Yes, we are. The stuff on the left column is the stuff that we're making space for that's easier to add. The stuff on the right column is basically impossible to add without changing the EOF version. We're doing these things here. We're doing it once. Ideally, we're breaking everything we can. So if we're just adding new opcodes, we're adding new byte sequences, But I think these are the two standards. If we're making the invalid byte sequence valid, then that's fine. And we're treating all prior contracts the same. And so these things don't require a contract version bump. We don't have to change the EOF version if we're just simply making new stuff. But if we're changing semantics like self-destruct, typically that's incompatible. If we don't execute contracts the same as self-destruct anymore, typically incompatible. And we're getting rid of features. You can't do arbitrary jumps from call data code. Again, we're also removing that. So these are the sort of things that we would try to avoid. And these are the big things we listed. So this might be a backup slide we could have up to say, well, how are you going to handle adding new features into EOF that, with their smaller features, like the new opcodes we're looking at putting in, like EVM Max is a great example of a compatible change. It's just a bunch of new opcodes, it's adding functionality, and it's not breaking things. And we would, it could still go into EOF v1, just with a future reversion like EOF v11, what we would call that, or the like what we're doing today with all of our fork versions of the EVM. So, and I couldn't resist the main. So here's my list of things we were breaking.
So would you suggest are you volunteering to run maybe a shorter version of these slides?
Yes,
tomorrow?
I can trim these down. I can get a revision ready in a few hours based on what I proposed. Take all the cutesy stuff out and get it down to 15 minutes.
Yeah, I think that would be nice. I would definitely try to focus on the structure you suggested, which may need, some changes to this. And
Right.
I feel like maybe, some of the slides are maybe too detailed.
Agreed.
I mean, yeah, they can stay detailed, but maybe we don't need to talk about each of those points, just on a high level.
Yeah, I think I agree. Take out all the detail. Okay. Yeah, so
yeah,
I'll get this going. Go ahead.
I will be around late tonight.
I'll be around. I'll be on the call
to help with this.
Yeah.
Yeah. No, but I mean, to review any different versions of the slides or any of that.
Yeah,
But yeah, tomorrow I will be on the call, of course. I think everybody else from Epsilon going to be there. Yeah, I mean, I don't think, yeah, maybe there's some pieces where we probably should speak up as Epsilon. Just that it doesn't come off that Epsilon has stopped working on this, because we haven't. But I don't think it has to be us presenting it, because you do have a good set of slides and a good story. So I think you should be doing it.
Okay.
I just want to avoid the notion that Epsilon is done working on EOF, and then, because that would be like a bad signal, right? So that's maybe the only thing we have to somehow avoid. And I'm maybe gonna be there. I'm not sure if you have any suggestions how, or is this even like a valid concern?
Okay. All right, so I'll start trimming these down. I should have. You guys Epsilon's mostly Europe-based, right?
Yeah.
Okay. So I'll probably just need to wake up earlier and check my Slack well before. Sometimes I wake up right before Alcor devs, but I'll be a bit more responsible this time.
Yeah, maybe don't sleep through Alcor dev, this time.
Haven't done that yet. Cool.
I'm probably going to take at least an hour break, if not two, but otherwise, yeah, I'm going to be available late, which means for at least another 5 hours, 6 hours.
Okay. Yeah, I'll try and get something ready within 2 hours. So take a 2-hour break.
Sounds good. I mean, yeah, this was my feedback. I'm not sure, Radek, Andre from Epsilon, any feedback from our perspective?
No, I'm fine with this. So thanks, Dana, for the volunteers and this presentation. It should be great. And I also will be available tomorrow morning to review it.
Cool. So I'll get slides updated within 2 hours, and then plan on when I'll wake up tomorrow for full feedback. So
Yeah, great. Thank you.
great, thanks.
Awesome. Charles, do you have any feedback to the slides?
Not on the slides exactly, but I think, Axel, you mentioned being confident about the proposed changes, and I think that from Viper's perspective, I would be most confident if there weren't any performance regressions being introduced in EOF, and I'm talking about code size regressions.
I mean, those are really. I mean, which one is the biggest one? Is the return data load, or
I think the
the
biggest
jump
one
F?
is actually the jump FI, yeah, or the stack validation rules.
Yeah, I think on confidence with those, I guess we are tending towards, like, on the jump F question at least, we're tending towards choosing one or the other, right? So it's a matter of which is the better solution. And it's not a question whether something will change. So I think on that, maybe we can be like more confident that question will be solved. Maybe there's less confidence on the return data load because it's yet another instruction, but I tend to be, I think that again, Solidity would be in favor of because they raised it before. So I think in terms of confidence, whether some of those features would be liked by the compilers, there's no lack of confidence there. The only issue we have is this recurring issue of too many instructions and too many changes, right? That's the only downside.
Yeah.
So yeah, Dano, do you actually have any idea regarding because this question probably gonna come up, right? It's just so many instructions. Do we have a good answer to that?
So yeah, I was going to put together a page on testing. I think one of the things we have going for us is I think EVM testing is more understood now than it was a few years ago. We've got a couple of great fuzzers. Guido V is writing an amazing fuzzer that's getting some amazing findings. And we don't need to have these large interop events because you can test the EVM in isolation. You don't need to test gets EVM interacting with Besu's EVM. There's no interaction. There's only one set of inputs. So it's a lot easier to test these. There's a lot less DevOps setup. It's mostly setting up time grinding on the fuzzers. And we would just need to write a fuzzer against the container format. We need to write fuzzers that generate extra code sections to exercise that code. And of course, the fuzzers that exercise the current operations. And some of the findings from Marius and Guido are that as far as the legacy EVMs, all the active EVMs that are live on the network right now are all giving the same answers. So we've got tools that'll get us the signals we need, which I think is we didn't quite have these tools last, before the merge. I don't think we really quite cracked the nut on how good fuzzing was going to be in finding all of these issues. We didn't have good enough fuzzing frameworks for this back when we were doing the Berlin and those types of changes. So I think we've really improved the testing. So I think I'll put a slide together on testing as well, saying that it's getting simpler and it's better understood, and we have a lot of the framework already in place.
So I guess you will have a slide regarding testing. And
Testing.
what you said on fuzzing.
Yeah.
Yeah, I think the two parts is testing 1 and 2, which I think you cover on the slides, is these big these big changes like code and gas observability. It's just an implication. They depend on these new instructions. And in fact, I think for most of them, they were the equal number of instructions. We don't really add many new, but we disable as many. Maybe the only exception is, so like for data observability, we are kind of equal or less. For creation, we do have more because of the return contract. And maybe jumps, it's a bit more instructions than what we remove.
So code sections is new. New unlimited dupe and swap is new. There's no deletes there. Let me go back down my list.
Do you think maybe we should have like a table of these instructions are added, these are removed, and what's the balance?
That would be, I think, interesting and valuable.
It would be what, sorry?
I think that would be valuable to have that table.
Yeah. Yeah, it's like a double-edged sword, but on one side at least, depending what number we get, on one side at least it shows that, okay, yeah, it's a lot of instruction, but we also remove a lot. And if the difference is really maybe like 5-6 instructions, then I think we are kind of good, because it's not significantly more complex instruction count-wise. It's just a lot of them are replaced.
I feel like we can also just start killing off dupe and swap instructions.
Yeah.
Because nobody really, they're not that well liked.
Yeah, we're net 1 here. That's good. Yeah, I think we're like net 1 hand. It's the call F and the ret F, I think, are where the real ads come in.
All right. Yeah,
All right.
let me know if I can help with the slides in any way, but at least I will be able to review them.
Yeah, I'll get to a first pass. I'll start churning from here for a couple of hours and then share it on the EVM channel.
Right. This was a monster marathon of EOF call, but it was worth it. I think we got most of it sorted. Yeah, Charles, don't be concerned. I think the size regressions it's gonna be sorted. So yeah, I wouldn't be concerned with the size regressions.
Yeah, okay. And I also want to emphasize the importance of exchange, but we can all get on the call with Solidity and discuss that.
Yeah, exactly. I think it's better if we first get consensus between Solidity and Viper with these like 2 outstanding questions. And I wouldn't raise eyebrows on all codevs before that. There's no point. Because we know there's going to be a solution to it. We just need to organize that discussion.
You wouldn't raise what? Sorry?
I wouldn't raise any eyebrows on all codevs that, oh, there's one outstanding question here. And,
Yeah, okay.
I wouldn't give extra ground to skeptical people. All right, awesome. I have nothing else to say. So from my perspective, thank you all, and see you tomorrow.
All right, thanks.
Guys,
Yeah,
see
thanks,
you.
Tyler.
Thank you. Bye.
Thank you. Bye-bye.